Now we want to identify the total and net ionic equation for this double displacement reaction where aluminum sulfate and barium chloride swap partners and form aluminum chloride and barium sulfate. Okay? We notice that the aluminum chloride is an aqueous solution and the barium sulfate is a solid. Now if we write out the total ionic equation for a salt, which is an electrolyte, the anions and cations exist as free-floating ions. So I would have 2 aluminum plus 3. Now these are solvated in the water, and I'm going to leave out the AQ. Anything with a charge here I'm implying is AQ. Plus 3 SO4 minus 2. Let me put that S in there. Now I have 3 Ba plus 2 plus 6 Cl minus. This forms 2 Al plus 3 plus 6 Cl minus plus 3 BaSO4 as a solid. Now what we notice is that the ions in the product that is aqueous are on both sides of the equation. That is, I have 2 aluminums here, 2 aluminums here, 6 chlorides here, 6 chlorides here. So these are what we call spectator ions, and I started with aluminum floating around, and I ended with aluminum floating around. It didn't do anything. I started with chloride floating around, and I ended with chloride floating around. So the net ionic equation would be, what did I make? Okay? My barium cations attracted my sulfate anions, forming barium sulfate. So this is the net ionic equation. Now if on the exam you're asked to write out the net ionic equation, don't go through the total ionic. If this is a salt, if it's an acid, it's a different story. But if this is a salt, you know these are the spectator ions, so you know you make 3 BaSO4 solid, and the barium cation came from one of your reactants, 3Ba plus 2, and the sulfate ion came from the other reactant, 3SO4 minus 2, and this explains the chemistry that you did. You made an ionic compound. There are now ionic bonds holding the barium to the sulfate, which has grown a crystal in your solution.